Okay, good morning everyone. We can as everyone here except for Taba.
Only Farah, not yet.
Oh, okay. So as usual, please click this link. Okay, and I will give you a code 78518. 78518.
Teacher, are you presenting on the last point?
No, I'm not. Not yet.
Okay.
Farah is not here, right? I will call you. I call her in the group first. Farah. Uh, okay, so where's others? I think still got four more, right? Two more. Saji, Eugene, Lakshmi. Where is Lakshmi? Another one is Dinesh, Ashur, Abhi, Janet, Ken, Kirtika, Krisha, Lakshmi, Nirupa. Where is Nirupa? Nirupa, are you here? Nirupa. Can anyone text her, ask her to join the class point? Or maybe she has any problem to join?
She's not responding.
Oh. Okay, so never mind, we just start the class first. Okay, so let's continue. I think we still got like two questions that we didn't answer in the reflection topic, right? So we continue that one, then after that we goes to the refraction. Okay. Alright. So can try to answer for this one.
Teacher, I can't see the picture.
Cannot see. Others, can you see the?
Cannot teacher.
Cannot. All right. Wait. But someone just answered just now. You cannot see the.
I mean, we cannot see the slide, but we can answer the question.
Oh. Wait.
I can't do either.
Okay. Wait. Is there any problem? Hmm. Maybe I need to generate new code. Wait, I generate new code for you. Okay, so 83963. 83963. Eight three nine six three. Okay, I will try also. Let's see how. Yeah, Abi. Okay. Let's try. Why we cannot see the question? I also cannot see the
It's the
question.
same.
Maybe you have to open double tab, then one tab for the Google Meet, another tab for class point.
Before this, I don't know. Wait, let me share again. You don't need to use another code. That means not the code is the problem. Wait, I try to, because this one actually I copy from the another PowerPoint, so maybe that's the reason. Okay, so you don't need to change the code. Let's see, we try again. Yeah. So I know now I cannot copy from the other PowerPoint. Okay. Alright, then who's another one who didn't join? Teacher, my line slow. Okay, you just give the answer in the chat. Okay, so we can. Abi, you just give the answer in the chat, okay? Your line is low. So we close now. So let's see your answer. Okay, so it says a series of plane wave is produced in a ripple tank. Okay, thank you. Tank containing a uniform depth of water. So which of the following shows the correct relationship between the wavelength and the frequency? So we refer back to the formula V is equals to F lambda. So V over lambda is equals to F, right? So let's say if you increase the frequency, the lambda of the wavelength will be decreased. So this is actually the inversely proportional. Okay, so the answer should be C. Okay. Okay, very good. Okay, so let's move on to the next question. So this is the last one. So what happened to the wavelength and the magnitude of the velocity of water wave when it's reflected? So what is the characteristic of the wavelength, okay, after it being reflected? Writing mine. Farah is not here, right? Not here. Okay, so I just close. Did Farah join other class before my subject? We can?
Yes.
Oh. Okay, what happened to the wavelength and the magnitude of the velocity of water when it is reflected? Okay, so for the reflection, okay, for the reflection, the speed, okay, the frequency also and the wavelength will not change, okay, after it being reflected. But the only thing change is the direction of the propagation, right? So the answer should be A. Okay. So this one is just mention about the magnitude. So means the magnitude may be the number of it. Let's say 70 cm per second. So mean before and after is the speed is same. Okay. But let's say they just mention about the velocity, then the velocity will change because there is a change of direction, right? And velocity is the vector. So when there is a change of direction means the velocity also will change. So the answer is A. F. What does it mean? Is it answer answer F? Nirupa?
Teacher, I meant to put D.
Oh, okay. You want to put D. All right. The answer is A. Okay. Okay, so we finish for the reflection. So we move on to the refraction. Okay. So the refraction of water wave. All right. So diagram below, alright, shows a seawater wave traveling towards a shore. So observe the wave and compare their shape when they are away from the shore and when they approach the shore. Okay, so the wave refraction cause wave fronts to parallel the shape of the coastline as they approach the shore. Means they will follow the shape of the shore. So let's say this one, so they will follow. It's a curve like this, right? So if the curve like that, so it will be curved like that. Okay, so if we just follow the shape of the shore. Okay, so activity 1, what happens to wave, okay, as they propagate to different depth of water? Okay, so just now we learned for reflection. Okay, so for the reflection, okay, so for the reflection, all is same. Okay, the speed, the frequency, and also the wavelength, okay, is same. Okay, but for the refraction, there will be a change, okay, for the wavelength and also the speed. Okay, so you can see the diagram here. Okay, for the deep water, you can see the wavelength is much higher than the wavelength at the shallow area. Okay, so means the deeper the water, okay, the higher the wavelength, right? And also based from that, okay, we already know this is the equation. V is equals to F lambda. Okay, so let's say for the deep area, you can see the wavelength is higher, right? Okay, so when the wavelength is higher, of course, the speed also will be higher at the deep area. Okay, while at the shallow area, okay, if you compare the wavelength, so the wavelength is smaller. Okay, so when the wavelength is smaller, what will happen to the speed? So the speed will be decreased. So the speed will become smaller. Okay, so that's the difference. Okay, for the refraction, okay, the speed and also the wavelength, okay, is not same. It depends on the depth of the water. If let's say the depth of the water is deep, so means the wavelength is higher and also the speed also will be higher. But let's say at the shallow area, okay, so means the wavelength is shorter. So when the wavelength is shorter, means the speed also will decrease. Okay. So here you have to compare the frequency. Okay, so I just mentioned just now about the speed and also for the wavelength. So both will change. Okay, it depends on the depth of the water. Okay, but how about the frequency? Okay, for the refraction, the frequency is same. Okay, after or before it being refract. Okay, the frequency is same. The only thing that change is the speed and also the wavelength. Okay, so here it say compare the frequency. So the frequency will become same. So compare the wavelength. So wavelength at the deep area is higher than the shallow area. So how about the speed of wave? So the speed of wave for deep area is higher than the shallow area. Okay, next you have to relate the depth of the water to the speed of the water wave. Okay, so I already said just now. Okay, for this one, if the deep area, the wavelength is higher, right? So when the wavelength is higher, the speed also will be higher. So the relationship is actually directly proportional. Okay, so or you can see the deeper the water, the higher the speed of water wave. Also can, or you just can put directly proportional. Okay, and then the next part, you have to relate the depth of water to the wavelength. Okay, so now you already see at the deep area, you can see the wavelength is much higher at the shallow part. Okay, so means you have to relate how. So what is the relationship? The relationship also is directly proportional, or you can say the deeper the water, the higher the wavelength. Okay, so or you can just say it directly proportional. And the next one, you have to relate the speed of water wave to wavelength of the wave. So this one also should be directly proportional. So the higher the speed of water wave, the higher the wavelength. So this one you just can refer the formula here. V is equals to F lambda. Okay, actually refraction of wave, okay, it can occur in water, light, and also sound. Okay, but in this topic we only learn for water and sound only. Okay, because light we will learn that one in the light chapter. Okay, after this. Okay, so we only see these two, that is for sea water and also for the sound. Okay, so refraction of wave is the change in direction of propagation wave, okay, caused by the change in velocity of wave when the wave propagate from one medium to another. Okay, so means the change of direction of propagation. So you can see here, let's say there's a pencil here, right? So you can see that the pencil is like bent like that. Okay, so this one is actually because of the light being refract. So there is a change of direction here. Okay, so that's what happened. Okay, that is for the light. So because of that, okay, there is a change of velocity when the light enter from the air to the water. Okay, so why there is a change of velocity? Because of the density. Okay, for the light, is caused by the density. Density of air is different from the density of water. Density of air is lower the density of water. So from the higher density to lower density, okay, that will cause a refraction. Okay, but for the water, is actually depend on the depth of the water. So because of the depth of the water, the velocity change. Why the velocity change? Because of the wavelength change. Okay. All right. Then for this one, okay, and for this one, for the sound, okay, for the sound is actually also, okay, it's because of the density of air. Okay, the density of air for the hot air is lower than the density of air in the cool air. Okay, so means at this part during the daytime, so later we will see this one more details. So this one I just briefly, okay, explain just like not so much. At least you know what happened. Okay, so for this one at here, okay, during the daytime, the density of air here will be lower because the hot air will be at the bottom part here and the cold air at the upper part here. Okay, so this one at the below part here during the daytime, the low density. This one is high density. So the sound travel from the low to high density. Okay, so it occur because of the difference of the density. So this one, it happened because of the density. This one also because of density, but this one because of the depth of the water. Okay, but all these three will cause the change in velocity. Okay. All right. So speed of water wave is influenced by the depth of water, and this one because of the density. Okay. And this one is also because of density. So we will look closer this one. Okay, this one on chapter 6 later. So this one we look later when we come to the refraction of sound. Okay. So before this, I think you already learned in form 2, I think, the light chapter. Okay. So can I ask you something if you still can remember? Okay, let's see if I have okay, this is water. Okay, and this is air. Right? And this is the normal line. So let's say from the air, the light come from the air. Okay. So what will happen to the refracted ray? Okay, what will happen to the refracted ray? Is it move towards or away from the
Bend
normal line?
towards normal line.
Yes, bend towards normal line. Okay, very good. Okay, so this one you have to know. Okay, this is the basic thing. Okay, let's see if I have from water. Okay, and this is a normal line, and it goes to the air. What will happen?
Away.
Yeah, it will move away from the normal line. Okay, this one you need to know because later you need to draw for me the refraction of wave. Okay, when it pass through the perspect, okay, the perspex plate. Okay. All right, so after that, you already know there are three types, okay, of the refraction of wave. It's come from the water, from the light, and also from the sun. Okay, so from the water, we already see, okay, this is caused by the depth of the water. When the depth of the water change, of course, the velocity will change because the change of wavelength. Okay, so now, what is the question for refraction of wave? Okay, so let's say if I have a deep region and the shallow region, okay, then I compare. So V1 equals to F1 lambda 1. Okay, this is for the deep region. Okay, for the shallow region, also V2 F2 lambda 2. So if I arrange back the formula, so it will be like this, right? Lambda 2. Okay, and you know for the refraction, the frequency is same. So if the frequency is same means you can just equate, okay, this equation. So this is actually the refraction equation for wave. Okay. So that's the formula that you need to remember. Okay, so now we compare. So this is for the water wave, okay, if they say the refraction occur. So the angle of incident and angle of refraction. So this one we will look later detail when we draw the refraction of water wave. So when water pass through from the deep to shallow area, okay, the angle of the incident will become bigger than the refracted angle. Okay, but if the water move from shallow to deep water, okay, it will the incident ray will become smaller than the refracted angle. Okay, then how about the speed? Okay, deep to shallow, you already know the wavelength will be decreased, right? So means the speed also will decrease. And this one, okay, for the wavelength, okay, but for the wavelength will become decreased, okay, because of the depth of the water decrease, but the frequency is constant or unchanged. Okay, but let's see for the shallow to deep water, what happened to the speed? So the wavelength will increase. Okay, so the wavelength will increase, so means the speed also will increase. Okay, but same for the frequency, there is no change in frequency. Okay, so this one you have to remember. Okay. How does the direction of wave change when passing from deep to shallow water? Okay, so this is the normal line. Alright, so this is the normal line. Okay, this is the normal line. Okay, when you draw the normal line should be 90 degrees with the surface. So let's say if I have the surface like this. Okay, so let's say the surface like this, your normal line should be 90 degrees with the surface. Okay, should be 90 degrees. So this is how you draw the normal line. Okay, so for this one, it's already draw the normal line for you. Okay, so it comes from the deep to shallow water. So from deep to shallow water, this one should be moved towards the normal line. So the line you draw here must be closer to the normal line. Okay, so it move closer to the normal line. Okay, so here is it. Okay, it will be moved towards the normal line. Okay, but how about, okay, from the shallow to deep water? So I make 90 degrees here. This is the normal line. Okay, so this is the direction. So you can see it move away. Okay, it move away from the normal line. It move towards me, it will move here. Okay, so the line will become closer to the normal line. But this one is far. Okay, it move away from the normal line. So remember, deep to shallow water, it refracted towards the normal line. If shallow to deep, it moved away from the normal line. Okay. Alright, so how you want to draw? Okay, how you want to draw? Okay, so the first one, you have to draw the boundary line to separate deep, shallow, and deep and shallow region. So you label the region. So this one already being labeled. Okay, after that, you draw the line, okay, that represent the direction of propagation of incident wave. So let's say the wave move from the left to the right. Okay, so you already draw one straight line here. Okay, after that, what you have to draw? Of course, you have to draw the normal line. So whenever you have to draw the wave, okay, like any, let's say for refraction, you must have the normal line. Okay, so you draw the normal line. So remember, the normal line must be 90 degrees from the surface. So this is the surface here. So it should be 90 degrees. Okay, after that, okay, so from point O, okay, you draw the line to represent the direction of propagation of refracted wave. So you can see here, the wave travel from deep to shallow area. So what happened from deep to shallow area? It will move towards the normal line. So the line that you draw must be closer or must be towards the normal line here. So this is the normal line. Okay, so it must be closer to the normal line. So this is the normal line, so it move closer to the normal line. All right. So after that, okay, it goes to the deep area again. So again, you have to draw 90 degrees. Okay, 90 degrees from the surface. So this is the surface. So this should be 90 degrees. Okay, now from shallow to deep area. So from shallow to deep area, the line, the refracted ray should be moved away from the normal line. So you see here, it moved away from the normal line. Okay, so means what you have to do first, you have to draw the direction of the propagation first. Okay, just don't simply draw the wave first. Okay, draw the direction first, then after that you can draw the wave. Okay. All right, so after that, you already finished draw the direction here. What you have to do, all the line here you have to draw, then the line must be 90 degrees from the direction of the propagation. So here you can see this is the direction, right? And you see the line here, all is 90 degrees, okay, from the direction of the propagation. And for this one, okay, so it should be 90 degrees. So this is the direction and this is the line. So you see it 90 degrees, right? So here after it come up from the shallow area, okay, so you have to draw 90 degrees, okay, based from the direction of the propagation. Okay, so that's how you want to draw for the refraction of this is actually for the trapezium. Okay, this is the shape of trapezium, okay, for the perspex plate. Okay. Alright, so this one using the ripple tank. Of course, when you talk about the water wave, how you want to see the phenomenon of wave for diffraction, interference, reflection, refraction. Okay, so you must use the ripple tank. Okay, so let's see the video for the diffraction. Okay, so you can see this is actually the deep area, this one is shallow area, right? Okay, so this one from shallow to deep. Okay, so the wavelength here you can see is much shorter than this one. Okay, this one is much longer. Okay, so this one is a shallow area, this one is a deep area. Oh, sorry. Okay, so I hope you can see it. Okay, the difference. Okay. Okay, so move on to the next slide. Okay, so this one you have to draw for me. Okay, the wavelength. Okay, so let's try to draw it.
So you won't mind, right, if the lines are very a bit.
You cannot draw a straight line, is it?
Yeah.
It's okay. Just like maybe I know which one the wavelength is shorter, which one the wavelength is longer. It's okay. At least I can compare.
Okay, teacher.
Okay. Farah, did you already see the doctor?
Teacher,
Yes.
is it only me or they already give me the arrow?
Teacher,
Yeah.
once we draw, then if we press open slide again, the drawing gets reset again.
You submit, then it reset again. Wait, I try.
Okay, teacher.
Wait. I try to log in. Then how come Asher can submit? Wait, I try to log in, see what you see. Nice. Oh, sorry. 963. Yeah, let's say I just draw. Oh, okay. Right. Mine can. You submit, right? Not reset. Anyone have a problem like that? You open the slide.
Teacher, why is the ray straight?
Yeah. The wavelength is actually in the straight line. You don't need to draw you don't need to draw the normal line, because the normal line is actually
the arrow given is wrong. It's like to deep area to shallow.
Yeah,
Shouldn't it
teacher.
go downwards? Why is it?
It's
Deep
supposed
to
the
shallow.
shallow part must go down, right? But then here
No,
it's
no, no.
just
The shallow part should be like the straight line only, because if let's say if you draw the, okay, can you see? Oh my god. Okay, never mind. I just draw here. So you can see at the Google Meet, right, what I draw, or cannot?
Can.
Can. If I draw like this, can you see it? You can,
Yes.
right?
Can, teacher.
Yes.
Okay, okay. All right. So let's say this is the plate, right? Okay, and then this is the deep area. So of course you know this is the direction already been drawn for you. Then I said just now you have to draw the normal line, right? But the normal line should be 90 degrees. So the normal line is actually at the direction of the propagation here. So means there is no angle there. The angle is zero. So when the angle is zero, when you draw the direction of propagation, it just goes straight line like that. Okay, and then it come out also in the straight line, because your angle is angle of refraction is zero, so it means there is no like whether it move towards or move away from the normal line. So only straight line here, and what you have to do here at the shallow part, you just draw the straight line, but therefore the wavelength must be shorter, okay, compared to
Also,
the
teacher, you mean like if the incident ray is 0
zero.
degrees,
Yeah.
the shallow, deep, or whatever it is after that is also 0.
Yeah, because okay, there is
Ah.
okay. So let's say for this one, this is the shape that you withdraw after this. Okay, this is the direction of the propagation, right? So when you draw the normal line I said just now must be 90 degrees from the surface. So it should be here, right? The normal line. So you can see there is an angle here. So when there is an angle here, you have to decide whether it move towards or away from the normal. Is it okay?
I think I get it.
I think so.
Okay, because this one, if you draw the normal line, what is the normal line? Here is the normal line, right? This is the 90 degrees. This is the normal line. The direction of the propagation, the refracted, the incident ray is actually at the normal line. So when the incident at the normal line, there is no angle be formed. So when there is no angle, the angle is zero. What you have to do, you have just draw the straight line here. You just continue like that. This one also, if I draw the normal line is here, right? So it's the same place at the incident ray. So the angle is zero. Okay, so you just draw again a straight line like that. All right. So
So I have a question, teacher.
yeah.
So, like from shallow to deep, won't the ray diverge from the normal line? Like
Shallow to deep.
yeah,
Okay, you mean just now whether it move towards the
I
away
mean
from the
yeah.
normal line. Okay, that one is because of there is an angle. This one there is no angle. So when there is no angle, what does it change? Only the wavelength change. So mean here it become shorter, right? The wavelength. Okay. So this is the example. It becomes shorter than deeper at the deep area. So here after it come out, it will change. Okay, it will come back to the normal wavelength. Okay, same as this one. Okay, so because there is no angle of refraction, the angle is zero, because I just told you just now the normal line is at the incident ray. So when there is no angle of refraction, so how come there will be the angle of there is no angle of incidence, so how come there will be angle of refracted ray, right? Okay, because it's zero. The normal line is at the incident ray. So there is you don't need to decide whether it's refracted away or refracted towards. Only when there is an angle of refraction, then you have to decide whether it moves towards or you move away from the normal line. Okay, is it
okay,
okay?
teacher. I can understand.
All right.
Yes, teacher. Thank you.
This one I already show you the answer. Okay, so I just close this one. Okay. All right, already insert. Hmm. Okay. So let me see your drawing. See. Hmm. This is me actually. Okay. So for this one, there is an angle. Okay. So let's try this one. This one, where's the normal line? Okay. So you have to decide the normal line first. So when you draw the normal line, you got the angle there, then you must decide whether it move towards or away from the normal. Okay, just now you can see the normal line is it's just same place as the incident ray. You must draw the normal line, okay? You cannot draw, Asher. Teacher, how? Alright. Sorry, I didn't see the chat just now. Show me black screen. Okay, the normal line should be 90 degrees. So I give you a clue here. So this is the surface. So it should be 90 degrees. Like this.
Teacher,
Yes.
I third submit my drawing.
Never mind. Tadi 65. Ya. Are you okay?
Teacher,
Yeah.
my arrow kind of suicide. It went down, but then it didn't go all the way down. It just sat in the middle of the down.
Hard. I know it's hard for you to draw using a mouse. I just draw mine. Should be 90 degrees, right? Mm, should be 90 degrees from the direction. Ah. So it should look like that. Okay. But in exam you have to draw using a ruler, okay? So 90 degrees. Okay, I give you like 20 seconds more. Then I just close the. Okay, so let's see your answer. Okay, so this is my answer. Okay, so you draw the normal line. So this is the surface, right? So it should be like 90 degrees. Okay, should be 90 degrees from the surface here. Okay, this is my normal line. So it moved deep to shallow, right? So it moved towards the normal line. Okay, so you see this is my direction of propagation here. So it moved towards the normal line. Okay, you see very close to the normal line. Okay, then after that, it goes down here. Okay, so we have to draw again the normal line, right? So for this one, it moved away from the normal line because it moved from shallow to deep area. So you can see my line here. This is the normal line. Okay, move away from the normal line. Okay, and then what you have to do, the next thing you have to do is actually you have to draw the wavelength. Okay, so the wavelength, this is my wavelength. So of course, at the shallow area, okay, at the shallow area, the wavelength must be closer. Okay, if you compare to deep area. So you see it's shorter. Okay, and then here it will come back. Okay, like the deep area again. Okay, the wavelength come back same as before. Okay, when it's a deep at the deep area. Okay, so let's check your drawing. Okay, basically it's correct, but you just miss your wavelength here. Okay. What is this, Avinash? Okay, at least you draw the normal line. Okay. This is a normal line, is it? We can.
The green color one is a normal line.
The green color one. I thought this one should be 90 degrees. This one is the normal line, right? So this one should be moved away like this. Okay.
Okay, sure.
Alright. This one, Krisha, where's the normal line? Should be you have to have the normal line. And this one, why you move that way? Because the normal line is this way, right?
Teacher, the normal line is the dotted line, right?
Yeah, the dotted line. But this is the normal line. Then you go. This is the normal line is here, right? So it should be goes here. Okay, and then here again it goes here. Cannot go there. You have to go here. Usually it's the opposite side. Okay, it should go down like this.
Okay.
Lashmi. Okay. This is your normal line. No, your normal line is this one. Should be 90 degrees. You see this is the surface. So the normal line should be like this. Okay, not like this. This is not 90 degrees, right? Okay. No, I think it should go down here. Okay, this one is correct. Okay. Abi, this one you have to go down. You cannot go back straight line. You have to draw the normal line. That's why you have to have the direction first. Draw the direction, then after that you draw the wavelength. Okay. And then this one, what happened? It will move down here. Okay, Sharanya. This one, what's the normal line? This is a normal line, right? How come your normal line is at the same place as the direction of propagation? Okay, so this is wrong. Okay. This one, it should be away. Okay. Except, okay, Janet. That's the normal line. This is the normal line, right? I cannot see a normal line, so wrong. Farah.
Teacher, I didn't see a normal line. You presented a few minutes ago. I didn't see it.
How come you are the one to draw? You cannot see also. Okay, this one is the straight line like this. Okay. This one you missing the normal line. This one you have a normal line, but this one they don't have the normal line. Okay. So this is actually the answer. Okay. So it means it move downward like that. Okay, what if the plate, okay, if the plate in the convex or concave shape, okay, so this is the wavelength that will be produced, okay. So at the part they put the convex, okay, the convex plate, okay, this one will become the shallow part. So this one you can see the wavelength is decreasing. Okay, so convex, this one is acting like the convex length. So the convex length is actually all the wave will be converged, okay, will be focused to one point. So you can see they will focus into one point here, right? And why this one is a concave, right? So concave, they diverge, okay, they diverge the wave, okay. So the wave here will be spread out like that. So it will be spread out. But here also, here is a shallow part, okay. So you can see here the wavelength also here will be decreased. Okay, for this one you need to calculate. Can you remember the formula just now?
V equals to F lambda.
No, this one for V1 lambda 1 is V2 equals to V2 lambda 2. This is for the refraction. Because they compare two area, the shallow part and the region, the deep part. The shallow region and deep region. So you need to have V1 lambda 1 equals to V2 lambda 2.
Teacher, for the lambda, I just use H for now, okay?
Okay. So teacher, we need to use a protector in exam to determine is it 90 degrees. Yeah, if you want to make it like it's sure that it's 90 degrees, you can use a protector. That's a better way I think. But let's say if you can just estimate, it's also can. And one more thing, sometimes it depend on the teacher who mark your paper. If the teacher like very strict one, then we take the protector. Like for example, just now for the reflection, right? When you draw the reflected wave, right? Like for me, I will just like it say is, or I can see the angle is same lah. I is equals to R, right? Okay, so I just give the mark. But some teacher when they mark the paper, they really like take the protector, and measure, make sure it's same. So I'm afraid that maybe you will get that kind of teacher to mark your paper. So it's better for you to use a protector. Is it hard for you to answer for this one? You just substitute the value, right? I give you 1 more minute. Who still didn't submit? Okay, so only me. Okay, close. All right. So V1 equal V1 over lambda 1 equals to V2 over lambda 2. So it says here the plane wave has a wavelength of 2 cm and velocity of 8 cm per second as it moves over the surface of shallow water. So when the plane wave move into an area of a greater depth, okay, its velocity become 12. So what is the wavelength of the wave in the area of greater depth? Okay, so this one should be 8, right? So this one I put, this is a shallow part. So 8 divided by 2 equals to 12 divided by lambda 2. So you just cross multiply 24, lambda 2 is 24 divided by 8, you got 3. So 3 cm per second. 8? How come you get 3 cm only? Oh, they ask you, sorry. Lambda, right? Oh my god. Yeah, correct. Oh, you put H. Okay. 48. How you got 48? Oh, you divide. Should be cross multiply, right? 0.75. I think we can. Yours is supposed to be 2 divided by 8, right? 2, is it?
8 over 2.
8 over 2, then why you got 0.75?
I think I did wrongly somewhere there.
Oh, okay. So check again, right? Okay, so how about this one? This one, be careful about the irony divide. Yes, you should be like cross multiply only. Okay, this one you have to be careful of the wavelength. The wavelength is not 12. So you have to calculate what is the wavelength here. Okay, and one wavelength is equals to how many cm? Okay. Okay, so others, can you answer it? Okay, Krisha, Avinash, Eugene. Okay, done. Wow, Krisha. Hmm. Okay, very good, very detailed. Okay. Okay, so let's see your answer. So this one is said diagram shows a water wave move from one area P to another area Q at different depth. Okay, so calculate the speed water wave in Q. Okay. If the speed of water wave is P in 18 cm. Okay, so what you have to do here, okay, this is actually, you have to use this formula, right? Okay, so let's say this one, I take this one is P and this one is Q. Alright, and already mentioned here, okay, if the P of the speed of the wave, okay, for P is 18 cm, so I just substitute here. Okay, but the wavelength, okay, you cannot just straight away take 12, okay, so you have to count how many wavelength is here. So 1, 2, 3, 4, okay, and then you have to divide by 4 here. 12 divided by 4 is 3. So mean one wavelength is 3 cm. Okay, and then another one, this one you need to find, right, the speed of wavelength, okay, in the Q region. So V2 and the lambda 2, again you have to count how many wavelength is here. 1, 2, 3, 4, 5, 6, 7, 8. So 12 divided by 8, you will get 1.5. Okay, and then after that you just cross multiply. 18 multiplied by 1.5. So you will get 27, right? So 3V2. So V2 is 9 cm as negative 1. So that's the answer. Lakshmi, how you get 80? Asha? Why most of you got 18, 4.5? This one, Krisha? 18 times 1.5 is 27, right? And then you divide by 2. Why you divide by 2? You should divide by 3, right? Not 2. I think you're...
Teacher. Oh
Yeah.
my god, I'm sorry. Oh my god.
All right. Yeah. I don't understand, teacher. Can delete one name in the class point. Okay. Which one should I delete? With smiley or with the one without the emoji. Okay.
Without the smiley.
Alright, okay.
Thank you, teacher.
Alright, welcome. So okay, Farah, you didn't understand. Okay. Wait for a moment.
Yes, teacher.
Okay. So I explain again. Others? Do you understand? Or maybe only Farah? We can, because so many of you got some of you got 4.56.
Understand, sure.
Yeah, okay. So we use this formula, okay? V1 divide by lambda 1 is equals to V2 divide by lambda 2. Okay, so I just state that V1 lambda 1 is for region P, while V2 lambda 2 is for region Q. Okay, so here they already give you that the speed for the Q, okay, the speed of water wave in P, is 80 cm. So I just put V1 here is 80 cm. Okay, then how about the lambda? So lambda at P, you can see here it give you from here to here. So this is actually more than one lambda. So you need to know how many lambda is there, how many wavelength is there. So I just count just now. This is considered as one wavelength, right? So one wavelength, two wavelength, three wavelength, four wavelength. Okay, so if I want to know one wavelength only, so I just divide 12 with 4. So I will get 3 cm. So means for 1 lambda is actually equals to 3. Okay, and then for this one you need to find the speed, okay, at region Q. Okay, but for the wavelength at region Q, there is more than 1 lambda also, one wavelength. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it got 8 wavelength here. So if I want to know only one, I just divide 12 with 12 divided by 8. So I will get 1.5. Okay, and then the next thing is you have to cross multiply. So 18 multiplied by 1.5 is equals to 3 multiplied by V2. So V2 is 18 times 1.5. This one is multiply, right? So when you change here, it will become divide. So the answer should be 9 cm as negative 1. Okay. So are you clear? Is it okay, Farah? All right. Okay, so for this one, it asks you to compare. So diagram shows a water wave move from region P to region Q at different depth. Okay, so this one, how you want to know whether is P is deep or Q is deep. Okay, you just have to see the wavelength. So here the wavelength is more higher than this one. This one is shorter. This one is longer. So means this one you have a this one should be a deep one and this one should be the shallow one. Okay, so which region is the shallow region? So the answer is Q. So why? Because of the wavelength are smaller. Okay, and then the next part you have to compare the speed and the frequency. Okay, so the speed at P is higher. Why? Because of the wavelength is higher at P. Okay, then how about the frequency? Remember for the refraction, okay, for the refraction, the frequency is constant. Okay, there will not any change, okay, in constant. In frequency. Okay, so for this one, you have to draw, okay, you have to draw a stair-shaped tank with 3 regions X, Y, and Z with their respective increasing depth. Okay, so a vibrator produces plain water wave in region X, okay, and it moves to region Y and Z. So you have to draw the diagram. So just compare the depth of the water. So you can see the deeper one is at Z, right? So after that is Y, then it goes to X. So for Z, okay, you have to know that this is to be the longer one. Okay, this is the longest one. So you have to draw the longest one for Z. Okay, and then when it goes to Y, okay, the wavelength will be decreased because the water now become shallow. Okay, Then after that, it move to Z, it become more shallow, so means the wavelength will be decrease again. Okay, so this is what you get from Z. Okay, the wavelength is longer. Okay, and then Y it becomes shorter, then X become more shorter. Okay. Okay, so this one you have to discuss the natural phenomena of refraction of wave. Alright, so it says movement of seawater wavefront from open sea towards the seashore is shown in diagram below. Okay, this is actually the cape part and this is the bay. Okay, so let me explain to you. Okay, so this one, the cape is shaped like the convex. Okay, so remember I told you just now, for convex there will converge. Okay, they will converge. Okay, they will focus all the energy, okay, to one point. So you can see all the wave here, okay, it being focused to one point. Okay, it being focused to one point at cape. Okay, but for the bay, okay, at bay here, right, it shaped like the concave wave. Concave lens. So concave is actually they diverge, they spread out the wave. Okay, so when they spread out the wave, you can see here the wave being spread out. Okay, it being spread out like that. Okay, so the energy also will be spread out. Okay, so here at the bay, okay, the water is more calm if you compare with the cape, right? Because the cape, the shape is look like the convex lens. So you know the convex usually that we converge all the wave, okay, into one point. Okay, so you can see here the yellow line here, okay, it focus at one point. But at the bay they shape like the concave, so they will diverge, they will spread the wave. So the energy of the wave will be spread out. So here the energy is lower. So when the energy is lower, okay, the water is more calm at bay. Right? So I hope this one you can understand. Okay, so here it said why the wave become closer to each other and follow the shape of the shoreline when they are approaching the beach. Okay, so here it said the water travels from deep to shallow region. Okay, deep to shallow region. Okay, then after that, of course, the speed will be decreased because of the wavelength is decreased. Because there is a difference of depth, right? When you approaching the beach, okay, so if the depth of the water will decrease. So means there will be a change in wavelength. So when there is a change of wavelength, there also will be change in speed. All right. Okay, so the water wave refracted towards the normal line. So that's why it will follow the shape, all right, of the seashore. Okay, when it approach the beach. Okay, so this one is actually why the water at the cape has a high wave. Okay, this one we just use the one that I explained just now. Okay, why at the cape? Okay, why at the cape the energy here? They have the high wave at the cape. Okay, so because of what? All right. So the more energy is converged. Okay, because it look like in a convex lens, so more energy will converge at the cape area. So that's why the water will have the high amplitude. Okay, so means the high wave is actually represent the high amplitude of the wave. Okay, so that's the reason. And why the water at the bay is calm? So this one is actually spread out because it looks like a concave, so it will spread out the energy. So that when they spread out the energy, the amplitude will become low. So the water at the bay is calm. So usually they will build a resort, okay, a resort at the at the bay area. So because the water is more calm there. All right. So I will stop until now, okay, because this one we already go to sound wave. It takes time to explain for refraction of sound. Okay, so do you have any questions for the refraction of water? So we already finished for the refraction of water. Is there any question you
No,
want to
no,
ask?
chair.
No. Okay. So I see you next week on Monday. Okay, for presentation. Okay, so I hope all of you are feeling okay. Okay. So take care everyone. Okay, so stay safe, right? Bye bye.
Bye
Thank
Bye,
bye,
chair.
teacher.
Bye.
Bye, teacher. Thank
Bye
you.
bye. Welcome.
Bye, teacher. Thank you.
Bye bye.
Thank you, teacher. Bye, teacher.
Bye bye.